Lesson: Predictive Analytics and Demand Forecasting. Predictive analytics and demand forecasting play pivotal roles in enhancing supply chain efficiency and resilience. As businesses navigate increasingly complex and dynamic markets, the need for robust predictive tools and methodologies becomes critical. Predictive analytics leverages historical data, machine learning, and statistical algorithms to anticipate future outcomes, while demand forecasting focuses on predicting customer demand to optimize inventory and logistics. Together, they empower supply chain professionals to make data-driven decisions, reduce waste, and improve customer satisfaction. Predictive analytics involves several steps, starting with data collection and cleaning. High-quality data is essential for accurate predictions, and organizations must ensure that their data is comprehensive, relevant, and up-to-date. Data cleaning involves removing inaccuracies and inconsistencies, which is crucial for building reliable predictive models. Tools such as Python and R are widely used for data cleaning and preparation, with libraries like Pandas and NumPy offering powerful functionalities to handle large data sets. Once data is prepared, feature selection and engineering come into play. This involves identifying the most relevant variables that influence demand, such as historical sales data, market trends, economic indicators, and weather patterns. Feature engineering, on the other hand, involves creating new variables from existing data to better capture relationships and patterns. Techniques like regression analysis and decision trees can be employed for this purpose. For instance, regression models can quantify the relationship between demand and various influencing factors, allowing for more precise forecasting. Machine learning algorithms are at the heart of predictive analytics. They can process vast amounts of data and identify patterns that might not be immediately apparent to human analysts. Algorithms such as random forest, gradient boosting, and neural networks are commonly used for demand forecasting. Random forest, for example, is an ensemble learning method that builds multiple decision trees and combines their outputs to improve accuracy and mitigate overfitting. Gradient boosting, meanwhile, builds models in a sequential manner, where each new model attempts to correct the errors of its predecessor, resulting in a highly accurate predictive model. Neural networks, particularly deep learning models, have gained prominence due to their ability to model complex nonlinear relationships. These models consist of multiple layers, each processing data to extract increasingly abstract features, leading to superior predictive performance in many cases. In demand forecasting, models like long short-term memory networks are particularly effective for time series data, capturing temporal dependencies and trends that traditional methods might overlook. The practical application of these models requires the use of robust software tools. Platforms like TensorFlow and PyTorch facilitate the development and deployment of machine learning models. They offer comprehensive libraries and frameworks that support the entire machine learning pipeline, from data preprocessing to model training and evaluation. These tools are invaluable for supply chain analysts aiming to implement predictive analytics in their operations. To ensure the effectiveness of predictive analytics, it is crucial to validate and evaluate the models. This involves splitting the data into training and testing sets to assess model performance on unseen data. Metrics such as mean absolute error, root mean squared error, and mean absolute percentage error are commonly used to measure forecast accuracy. A low error rate indicates a reliable model that can be trusted for decision-making. Real-world examples highlight the transformative impact of predictive analytics and demand forecasting in supply chains. Walmart, for instance, employs advanced analytics to optimize its inventory management. By leveraging machine learning algorithms, Walmart can predict demand for various products with high accuracy, reducing stockouts and excess inventory. This has resulted in significant cost savings and improved customer satisfaction. Similarly, Amazon uses predictive analytics to enhance its supply chain operations. Through sophisticated demand forecasting models, Amazon can anticipate customer needs and adjust its logistics accordingly, ensuring timely deliveries and efficient warehouse management. This has been a critical factor in Amazon's ability to maintain its competitive edge in the e-commerce industry. The integration of predictive analytics in supply chain management is not without challenges. Data privacy and security are major concerns as organizations handle sensitive information. Ensuring compliance with regulations like the General Data Protection Regulation is essential to avoid legal repercussions. Moreover, the accuracy of predictive models depends heavily on the quality of input data. Inaccurate or incomplete data can lead to flawed forecasts, undermining the entire decision-making process. To address these challenges, organizations must establish robust data governance frameworks. This involves setting policies and procedures for data collection, storage, and sharing, ensuring that data is accurate, consistent, and secure. Additionally, continuous monitoring and updating of predictive models are necessary to account for changes in market conditions and consumer behavior. In conclusion, predictive analytics and demand forecasting are indispensable tools for modern supply chain management. By harnessing the power of data and machine learning, organizations can anticipate future demand, optimize inventory levels, and enhance operational efficiency. The successful implementation of these techniques requires a combination of high-quality data, advanced algorithms, and powerful software tools. With careful planning and execution, supply chain professionals can leverage predictive analytics to drive innovation and gain a competitive advantage in an ever-evolving market landscape.